Hello students, welcome to my YouTube channel and welcome to the topic of trigonometry. In this particular video session, just we are going to discuss about the trigonometry problems based upon the submultiple angle. So here it is the first question. If tan x is equal to minus 4 by 3 and 5 by 2 less than x less than 5, then find the values of sin x by 2, cos x by 2 and tan x by 2. Here it is given that the value of tan x, it is minus 4 by 3 and the value of x lies in between 5 by 2 and 5. That means it lies in the second quadrant. So here it is given that tan x is equal to minus 4 by 3 and the value of x lies in between pi by 2 and 5. That means the value of x lies in between pi by 2 and 5. That means x lies in the second quadrant. So x lies in the second quadrant. So then we have to find out the value of sec x by using the value of tan x. Sec x will be equal to square root of 1 plus tan square x and it will be 1 plus 16 by 9 plus that is equal to 25 by 9 and it's square root 2. So whether it will be plus 5 by 3 or minus 5 by 3, it will be equal to minus 5 by 3 because the value x lies in the second quadrant and in the second quadrant sec function is negative. So the square root of 25 by 9 will be equal to minus 5 by 3. Then from the value of sec x, we have to find out cos x. We know that cos x is equal to 1 upon sec x, 1 upon minus 5 by 3 and it will be equal to minus 3 by 5. So the value of cos x, it is minus 3 by 5. So from the value of tan x, we are getting sec x. Then from sec x, we are getting here cos x. Now we are going to define the value of sin x by 2, cos x by 2 and tan x by 2. But the important thing is here, we have to convert this x into x by 2 form because it is given in the form of x and we have to evaluate the values in the form of x by 2, that means submultiple form. So if x lies in between pi by 2 and 5, then x by 2 will lie in between pi by 4 and 5 by 2 because just dividing a 2 in each of the three terms, we are getting pi by 4, it will be x by 2 and it will be pi by 2. But here we are getting that the quadrant is been changed. That means if x lies in the second quadrant, then x by 2 here is lying on the first quadrant because it is the first quadrant. So it is first quadrant. And we know that in the first quadrant, sine is positive, cosine is positive. That means sin x by 2 is positive and cos x by 2 is positive. Now we have to find out the values of sin x by 2, cos x by 2 and tan x by 2. So first of all, we have to go through the first bit of the problem. We know that 2 sin square x by 2, it is 1 minus cos x and it will be 1 minus the value of cos x. Here it is cos x minus 3 by 5. So it is 1 plus 3 by 5. So it is equal to 8 by 5. That means sin square x by 2, it is so simplifying it, we have 4 by 5. Then the value of sin x by 2, it is 2 upon root 5 because it is positive. Then the second case. We know that 2 cos square x by 2, it is 1 plus cos x. It is 1 plus minus 3 by 5. That means 1 minus 3 by 5. So it is 2 by 5. Cos square x by 2, it is 1 upon 5. So cos x by 2, it is 1 upon root 5. Then the third bit is here. We know that tan x by 2 is equal to sin x by 2 whole divided by cos x by 2. Sin x by 2, it is 2 upon root 5 whole divided by 1 upon root 5. So it will be equal to 2. So here it is the solution of the first problem. Then let us go through the second problem. So here it is, these are the two problems, number 2 and number 3, very similar to number 1. So these are tasks for you. Just you have to find out the values of these required conditions by using the given conditions. So let us go through the number 4. Here it is the question number 4. Prove that 1 plus cos x upon 1 minus cos x is the whole square of cosec x plus cot x. So let us go through the left hand side. 1 plus cos x divided by 1 minus cos x, it is 2 cos square x by 2 whole divided by 2 sin square x by 2, because the value of 1 minus cos x. Then it will be cot square x by 2. Then the value of, then that's the right hand side, whole square of cosec x plus cot x. It is 1 upon sin x plus cos x upon sin x. Then it will be 1 plus cos x whole divided by sin x and its whole square. 1 plus cos x, it is 2 cos square x by 2. The value of sin x, it is 2 sin x by 2 into cos x by 2. Then it will be cos x by 2 divided by sin x by 2 and its whole square. Then it will be cot square x by 2. So here it is, LHS is equal to RHS. So the problem number 4 has been proved here. Then let us go through the question number 5. So here it is the problem number 5. We have to prove that cos x upon 1 minus sin x, it will be tan pi by 4 plus x by 2. So let us start from the left hand side. Cos x whole divided by 1 minus sin x. The value of a cos x, it is cos square x by 2 minus sin square x by 2 whole divided by, it is cos x by 2 minus sin x by 2 and its whole square. Then it will be in the form, it is in the form of a square minus b square. So it will be cos x by 2 minus sin x by 2 whole multiplied with cos x by 2 plus sin x by 2 whole divided by, it is cos x by 2 minus sin x by 2 into cos x by 2 minus sin x by 2. So just cancelling the common parts from both numerator and denominator, we are getting here cos x by 2 plus sin x by 2 whole divided by cos x by 2 minus sin x by 2. Then just dividing cos x by 2 to both numerator and denominator, we are getting here cos x by 2 plus sin x by 2 whole divided by cos x by 2 and then cos x by 2 minus sin x by 2 whole divided by cos x by 2. Just dividing these terms, we are getting 1 plus tan x by 2 divided by 1 minus tan x by 2. Then it is tan phi by 4 plus tan x by 2 whole divided by 1 minus tan phi by 4 into tan x by 2. Then it is tan phi by 4 plus x by 2, which is the right hand side part of the problem. So here the problem has been proved. Then let us go through the question number 6. We have to prove that cot x by 2 minus tan x by 2 is equal to 2 cot x. So here is the proof. Let us go through the left hand side of the problem. Cot x by 2 minus tan x by 2, it is cos x by 2 minus sin x by 2 minus sin x by 2 whole divided by cos x by 2. Then taking the LCM as sin x by 2 into cos x by 2, it is cos square x by 2 minus sin square x by 2. Then it will be cos x whole divided by sin x by 2 into cos x by 2. Then let us multiply and divide, or you can say that let us multiply both numerator and denominator by 2. Then it will be 2 cos x whole divided by 2 sin x by 2 into cos x by 2. Then it is 2 cos x whole divided by sin x. Cos x over sin x, it is cot x. So here it is the right hand side part of the problem, and here it has been proved. Then let us go through the problem number 7. Here it is the problem number 7 and it's a solution. Prove that sec x plus tan x is equal to tan 5/4 plus x by 2. So let us start from the left hand side part of the problem. It is given that sec x plus tan x. Just convert sec x as 1 upon cos x and tan x as sin x upon cos x. Then taking cos x as LCM, here we are getting 1 plus sin x divided by cos x. Then you have to convert it into or you can put the formula of sin x as minus cos pi by 2 plus x, and in place of cos x we have to put sin pi by 2 plus x. Then just we have to take a 2 common from this pi by 2 plus x, and it will be in the form of 1 minus cos 2 multiplied with pi by 4 plus x by 2. Similarly, by taking a 2 common from this pi by 2 plus x, again we are getting here sin 2 multiplied with pi by 4 plus x by 2. Then we can put the formula of 1 minus cos x. 1 minus cos x, it will be in the form of 2 sin square x, and it is sin 2x, it will be 2 sin x into cos x. Okay, so it is in the form of 1 minus cos 2 theta, 1 minus cos 2 theta, it is 2 sin square theta, and sin 2 theta, it is 2 sin theta and cos theta. These two formulas are applied here. So it is 1 minus cos 2 theta, it is 2 sin square theta, and here sin 2 theta, so it is 2 sin theta into cos theta. Then cancelling the common parts from both numerator and denominator, we are getting tan 5/4 plus x by 2. So the major part is here in this particular step, because we are applying these two formulas. 1 minus cos 2 theta, it is 2 sin square theta, and sin 2 theta, it is 2 sin theta and cos theta. So here is the proof of the problem number 7. Then let us go through the problem number 8. Here it is the problem number 8. We have to prove that 1 plus square root of 1 plus sin x divided by square root of 1 minus sin x, it is tan 5/4 plus x by 2. So let us multiply square root of 1 plus sin x to both numerator and denominator. By multiplying, we are getting here whole square of square root of 1 plus sin x and square root of 1 minus sin square x. Then just simplifying these steps, we are getting here 1 plus sin x divided by cos x. Then we have to apply these two formulas here, sin 90 plus theta, or you can say that sin pi by 2 plus theta, it is value of cos of 90 plus theta, it is minus sin theta. Then again we have to transfer it into the form of 1 minus cos 2 theta, and the denominator into the form of sin 2 theta. So 1 minus cos 2 theta, it is 2 sin square theta, and in the denominator part, sin 2 theta, it is 2 sin theta into cos theta. Then just simplifying, we are getting here tan 5/4 plus x by 2. So here it is the proof of problem number 8. Then let us go through the problem number 9. So here these are the two problems. Task for you: prove that sin x upon 1 plus cos x, it is tan x by 2, and prove that tan 5/4 plus x by 2 plus tan 5/4 minus x by 2, it is 2 sec x. Then let us go through the last problem of this video session, number 11. So here is the problem number 11, the last problem of this current video session. Just we are going to find out the values of cos pi by 8, sin pi by 8, tan pi by 8. The value of a is equal to 45 degree, that means a is pi by 4. A is equal to 45 degree, that is pi by 4. A by 2 is 22 half degree, and it is pi by 8. Then we have to go through the two formula. The first formula is cos A, it is 1 plus cos 2A divided by 2. Then we have to go through another formula, sin A, then it is 1 minus cos 2A whole divided by 2 and its square root. The value of a cos A by 2, it is 1 plus cos A whole divided by 2 and its square root. Then another value, sin A by 2 is square root of 1 minus cos A whole divided by 2. So just applying these two formulas here, we are getting the value, and then in the second bit we are applying the value of sin A by 2 and then getting another value, and then at last the value of a tan pi by 8 For tan phi by 8, we are applying another formula, that is tan A is equal to 1 minus cos 2A divided by 1 plus cos 2A, and its square root. Then tan A by 2 is equal to tan A by 2 equal to 1 minus cos A whole divided by 1 plus cos A, and its a whole square root. So in the third bit we are applying this formula. So here it is all about the 11 problems of this current video session based upon the submultiple angle of the topic trigonometry. In the next video session, just we are going to discuss about another problem based upon this submultiple angle. Till then, thank you.